Alright, Crewton Ramone's How's the Math?
.com.
We got the boys here, DBOYZ doing, this is an actual lesson, and we've done it before, they've done these before, but now we're just doing more, and I'm going to just film an actual lesson. We'll see how long it takes. I expect this will be half an hour to an hour long, depending on if I decided to let the camera roll, or if we do, you know, edits and so forth, stop and start the camera, and have to clip them together. Alright, so here's all we're going to do for the parents or the homeschoolers or the teachers, because it's amazing to me that somehow you guys are able to split multiplication and division. They're inverse functions, right?
Mm-hmm.
Okay, 4 is that side, right?
Mm-hmm.
What's this side?
9.
Obviously, right?
Mm-hmm.
What's the whole thing? Well, what's 4 times 9? We can use our tricks. We can count by 4s.
Yep.
We can do lots of things.
What's 1 less
Let's do
than 4?
I don't know. What's 1 less than 4?
3.
Okay. And what does 4 need to be? 10.
6.
There you go. So 4 times 9, 36. We know that. Or we could count by 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36. Or the faster way is 9, 18, 27, 36. I don't care how you do it. At this stage of the game, we are just counting. But counting in mathematics, right, we want to be able to count very quickly. So that's what we're going to do. See that? So for each one of yours, and you can see here, we have multiple ones for him, and a bunch of ones over here for you. And that's all you have to do. Count the sides, and then write the whole number underneath.
Me?
Yep.
I can do
Everybody, you guys do it. Go, start.
50. 1. Oh wait.
Alright, the 1. Start with the 1. You got a 1. So just put 1. And you're gonna have a whole bunch of. Here, try and make it straight. Or in other words, 1, 1, right? But it's okay, however you do it. He's 5. Beautiful. That's great.
1, 1.
How about this one? 4. Good. And then it's how many this way?
Put 3 right here.
Sure.
1.
Good job.
3. Backwards 5.
You make your 5 correctly.
Okay, I'm gonna write 3.
On
the hill, I'm gonna write 9.
Yes, correct.
15.
Very good. So how much is it total underneath there? And see, a lot of times this is a task where you can walk away. You let them do it, and then you come back. And then the fun part is checking it, right? Making sure, that's the exciting part. When you lift it up, did you get it right?
Yeah.
Right? Like under this one. Oh, what if they put the wrong, right? Okay. How much is under there?
40?
You gotta count everything.
Oh yeah.
Oh, yeah.
15.
Now what's the fastest way to count that? I don't know. Don't look at me. It's your math. What's the fastest way to count that? Okay. So put that there, put that there. You need another 3 over here, because you gotta count both sides. You gotta count 2 sides. That's a great 3. Did you put a 9 underneath there?
60.
Very nice. Alright, then put 60 underneath there, right there someplace. It's fine. It's fine, just leave it. Julie Marcus, next one.
Okay, I'll start with the 2 next. Okay, 2. 60.
Good.
Now comes the easy part.
Yeah.
1, 2.
Okay, we need to work on you writing 4s. End of the first kindergarten, and there's still, alright, whatever, anyway.
Thank you.
And he's doing his. What's underneath there?
I'm going to do my 4s.
Okay, fine. Here, like I said, that's it. We're just, right? It's fun. They get to use markers. They get to write. They get to hide numbers.
From the grown-ups.
From the grown-ups.
So they don't find out what we're doing.
Right. So you can make your secret numbers underneath there. Good job.
Secret.
Okay, let me show you how to write it. That's a 4. All right, make a capital L and put a line through it. That 4 was fine.
So I put it.
Let's try again. Make a capital L. Can you make a capital L?
7,
Yeah, a little bit bigger.
7, 14,
There you go, and then put a line through it.
21,
That's it. Need another one down here. Or up here.
I counted by
You can put it on
sevens on
top.
this one.
How about I put it like
You
that?
counted by sevens even though it was fours? That's great. Good. Good, good.
That's a good idea.
Alright. Hey, you've got room.
Tiny. Yeah.
2, 4, 5,
Put it here.
6.
You already counted that side. This side and that side are the same. You need to count that side. Or you need to put it there.
7,
It's not just
7,
four.
7, 7.
You're right. It's all just four. You're correct. It's all of it. It's four. It's a square, right? Excellent. How much is going to go in here?
7, 9,
16.
There you go. Put it in there.
7, oh wait, 9,
1.
110
Okay.
and 6 units. Good at that.
63.
Then-
Good job.
63. I got it.
Excellent. This one? Or you got these guys over here to do too?
Okay, 6.
So is this kind of fun? A little bit?
Sort of boring.
Sort of boring. Boring and fun at the same time, huh?
Fun. Okay.
Back me up.
5.
3 and 6.
Mm-hmm. Write them down.
3
Mm-hmm.
and then 6.
Mm-hmm. You could make a smaller 7, you're right.
6. So what's going on here?
You know it's a 9 there. Just make a smaller 7. Okay. A 5. You can put the 8 up here, just so there's room. That's a cool 8.
8.
So what's got to be underneath there if you have 5 8s?
18.
5 8s is 18?
I'll use mine.
Yeah, I know, you're just joking.
Yeah.
It's funny. We do math jokes. When you get the answer completely wrong when you know it's silly, that's funny, right?
Yeah, that's the
Cracks
whole,
me up because I mean,
that's the whole thing that
how many
I love
households are
about
like
math.
that?
I
Yep.
love math when it happens.
Yeah, I love math when it happens too. Oh, cut it out. Alright, put the blocks back. There you go. So do that. Now what about this one? And what about this one? And what about this one?
I'm still way behind.
6, 8.
Oh no, I only have this one, this one, this one.
You're fine, just write. Don't worry about who does it first or anything, just write it down. Where'd your other 6 go? You lost a 6. So what did you put underneath there? You haven't put anything yet.
2, 4, 6,
Alright.
8, 10, 14.
Mm-hmm.
Oh, I can count it easy. 7, 14.
Excellent. That's good. That's good, 18.
I
We
got
like it. How about this one?
5 and 5. I was just making a good.
Just make sure. Alright. That's always good. That's what you want to do. You want to be curious.
7, 14.
Right? Count twice. But we need a
I
lot
was
of
making
a
sure.
lot of scientists
5.
need to do the same thing, right? You want to just make sure you know, but let's just make sure.
5
You
and
don't want
5.
to discourage that.
So it's
7,
What's 5 times 5?
7, 14, 21,
Look at him.
28,
What do you got? Count by 5s.
45.
Very good.
25 is 25.
Yep.
I just care about the
Alright,
25 is
good stuff.
25.
Oh, what are you counting? Which one are you counting?
He's counting the 14s. No.
This one? Yeah. Oh, you're counting 7s. Yeah, that takes some work, huh? Now you'll notice you got lots of 7s because you're the big brother, and he got a few 7s.
7,
but still had to
14,
count.
21.
There you go. You're already done. So you got 7, 14, 21 here. Then what? 28.
Yeah.
And then I just heard you say 2 takes
35.
35. Then what? Then take out the 5.
There's 7. I mean, 2 left.
Right. So what do I have?
40.
Mm-hmm. What's right there?
42.
Yeah. And then what?
2.
53.
How'd you get 53?
Oh.
I added 7. Wait a minute. I added 7 to 2, and I got the 53.
Huh?
Yeah, exactly. Huh? Huh? Wait, do that face again. Wait, do that face again. Huh?
Huh? That's not real.
Yeah, that's. All right. So what's 2 and 7?
I want you to wait my 7th right now.
9. 59.
How'd we get to 59?
Oh, 49.
Okay. Count it again.
He had one left.
7, 14, 21, 28.
Let's see this. 21.
7, 14,
21.
21.
And it's
8.
Mm-hmm.
35.
Mm-hmm.
40, 42.
Mm-hmm.
49.
Is that 7 over here?
Let me just put it like that.
Now notice, you remove the no from the lesson. All right, ask them what they have. They write an incorrect answer. Just ask it. Yes. All right. Are you done?
No, I'm doing 13.
Oh, you got to do the 13s.
7.
Okay.
And
the 7.
there's 3.
Is that 7 there? Count along here.
And 3.
I got 3.
Yeah.
13.
Look at it one.
3.
Oh, so it's 10 together.
If I added 3 and 7, that comes in very handy for algebra later, doesn't it? We're counting
Yeah.
x's and stuff. But right now, hold on a second. What goes first?
And
Very good. Nice.
Oh,
21. So get the 1 there.
1.
Okay.
done.
All right. What'd you put underneath here for 13? Oh, very good.
You put
All right.
13 on 14.
All right. Cap your pen. Sit down nicely.
Now I have to do my 8.
Sit down nicely.
8.
Then I say wins.
All right.
Just goes
There was no race.
8.
Just sit down nicely
16.
and
8,
practice.
16. Is it 8, 16?
Yeah.
8, 16.
Mm-hmm.
8, 16.
Mm-hmm.
Twa.
What comes next? What does the 6 want to be?
6 wants to be 10, so it takes the 4 and 8.
Yeah.
4 left, so 42.
What? Say it the other way.
24.
Yeah, there you go. That's common, actually. And
Hey,
anyway, all right, keep going. Okay, so now I got 24. What's 4 want to be?
10.
So what's he take?
He takes the 2.
A 4 takes 2 to be 10?
4 takes the 2 to be 10. No, it's a 14 if you add the 4 to the 8. Or the 14 to the 8. So it's.
I already know that.
I don't know what he's doing.
Like, what the?
What are you doing?
I'm just confused.
Oh, okay, you're just confused. Let's count. 8,
8,
16,
16,
then what?
24.
24. Now what? The 4 wants how much to be 10?
The 4 wants
What does 4 need to be 10?
6.
All right,
6 out. 3 left. 2 left.
right.
So then 80. No, 40.
Where were we at? We're at 24. What's next? 30.
2.
There you go. So write the 32 under there quick before you forget.
40.
Now the other thing you can do, and these boys don't do it,
4.
is you can get 10s out. And you can just line the 10s up along the bottom there, and then they can put the numbers and they can count that way. But these guys don't do it that way. But you could if you wanted to, right?
You can also
That way you
count-
use your 10s as a measuring stick,
Brother,
right?
you could have also counted by 4s.
You could also count it by 4s. 4, 8, 12, 16, 20, 24, 28, 32. Right?
26.
You know how to count by 4s.
26. Next.
Alright, anyway. And 36 would be next if we were counting by 4s. Alright, good. Now, last one. You need to do this one and we're done.
Easy.
Yeah, super easy, just fast. He gets to write numbers, it's fun.
I know.
But then, no.
So, put the 5 over here if you want to. That's a great 5. And then what about, just put a 10 there. And what's 5 10s?
5 10s. 50.
Well, quick, write it down. Oops, right, yeah, went backwards. Alright. And all these things will be corrected over time. Nothing to be afraid of or worried about. Alright. So, like I said, they're just regular kids. How much trouble you want to be in?
None.
Alright. Now, we have all of these.
Done.
Here's what done. So now let's go, and I'm going to take this black pen. And you find all your numbers that are square on yours.
Me?
Yes. And then we'll give you a black pen too.
Let's get
You
the
just
one.
mark it. Just put a mark next to it. Yep, the one is square, definitely. Just put a mark anywhere there. Just put a mark like this. Done. Next one. Find another square number. Good. Find another square number. Good. Find another square number. Any more square numbers? Ooh, I see another one.
Online? Done. 2 square numbers.
And you had 2 square numbers. Okay, so we can see the numbers that are square. Alright, that's good. So what's the square root of this one?
I cannot. I
After
know
10,
my
son.
square. 6.
What's the square root of 36?
6.
Right, because all the sides are same. What's the square root of 16?
4.
What's the square root of 9?
9. 3.
What's the square root of 9?
3. 1.
Square root of 9 is 1.
3.
Alright. Which one is the 9 anyway? Where's 9? Okay, pick it up. There better be a 9 under there. There you go. Right? Okay, put it back. What's the square root of 25?
5.
What's the square root of 4?
2.
Alright, super easy ones, right?
Easy.
Alright, now, so let's talk a little bit more about this. Let's take a look at this one. I have 14 students. Right? I have 14 students, and I'm going to divide them into 2 rows. Right? 2 teams. How many in each team?
7.
Easy, right?
7.
Super easy. And you can see it right there. And you can, if you use your little imagination, you can see each one of these as students, right? There you go. And take out the 7 and right, measure just in case. Alright, let's say I have 7 rows of 9 chairs. How many chairs? Which one is it? Point to it.
63.
Yep, which one is it? There you go.
63.
So if I had 63 and I wanted to put the chairs in rows of 9, because I couldn't fit 10, so I put rows of 9, how many rows would I have?
Seven.
Very good. Why did it take you that long to figure it out? Come over here and look, you, the younger boy. I have 63. See them? There's 63, and you gotta use your imagination. Each one of these is a chair. I put them in rows of 9. I'm gonna have 9, 18, 27, 36, 45. What's this next one? Do you know?
50.
56, 63.
63.
Is that right?
Yeah.
Is it 56?
Huh?
Does that sound right?
Huh?
Does it sound right when we're counting 9s? Does 56 sound right?
Huh? I'm just confused if that is. Wait.
Don't just be confused.
Oh,
Is
yeah.
that right?
No.
Is 56 right? What is it? What's 5 times 9?
5 times 9
Mhm.
is
Think about it.
45.
There. Okay. Then what's the next one? What's 6 times 9?
54.
Very good. And you're just using that rule, right? What's 1 less than 6?
5.
What does 6 need to be 10?
4.
So what's 6 times 9?
56.
56?
Oh, look.
See,
54.
there you go. I never trust a teacher.
54.
All right, let's count it again. 9, 18, 27. Then what?
27.
36, 45. And listen to the pattern. Because when I have 18, that's 1 and 8. Then 2 and 7. Then 3 and 6. Then 4 and 5. Then 5 and 4. Then 6 and 3. Right? Does that make sense? Right? It just goes, one goes up and the other one goes down, right? The tens goes up and the units go down. Does that make sense?
Yeah.
Okay, count it again for me, please. 9s.
9.
Count it.
9.
9,
8.
18,
26.
20. Don't try to mumble your way through it. 9. Crack me up. 9, 18, 27, 36. Oh, let's point. 36. Then what? 36. 45. 54. 63. And here's another thing. Think about this. What's 1 plus 8?
9.
What's 2 plus 7?
9.
What's 3 plus 6?
9.
See, if they don't add up to 9, what's 5 plus 4? Or 4 plus 5?
9.
9. What's 6 plus 3?
6 plus 3 is 9.
Does it ever not add up to 9?
No.
If it doesn't add up to 9, like 56 doesn't add up to 9, you've made a mistake. Right? Okay. Let's take a look over here. You've got 21 students.
Wait, here.
I don't know, you tell me. 21.
Wait.
Okay, and I'm gonna split them up into 3 rows. 3 teams. How many on each team?
7.
Very good. If I take 3 teams with 7 kids each, how many kids?
Huh?
3 teams, 7 kids each, how many kids?
21.
Very good. Like I said, how is it possible that you guys are out there teaching mathematics and you split division and multiplication into 2 different years of study? Further, how is it possible that you can take a look at something like this where we make rectangles and we don't talk about area a little bit? That this is perimeter and the whole thing inside is area. So if I have a piece of land that's a piece of property, a piece of anything that's, we'll say, 3 miles by 7 miles, the whole thing is 21 miles. Right? 21 square miles. Make sense?
Yeah.
All right. So if I had like over here, if I have, what's the area of this thing?
42.
Okay. And how did you find that? Because why?
Because I was like,
this side is 8, this side's 4, and you picked it up. I know. Why do you, like, if I told you one side's 8 and the other side's 4, what's the whole thing?
42.
All right. Excellent. How about this one? If I have, and how about over here? Fastest way to do it is this is 40 and this is 20. 20 and 40 is how much?
60.
And it's super easy because we got zeros.
Hey,
20
this is my pen.
and 40.
It's okay for me.
Right? And literally, that's how it is. 20 and 40.
I'll help you cap it.
Alright? Oh, sure. Go ahead if you want it. Capping the pen is kind of fun. Alright. Okay. Let's take a pause.
A cup.
Oh, wait a minute. We're not done. We're playing under the cup is fun. Always. But, wait. Let's do this. Real quick. Quickly. What's 0 and 0?
0.
So what's 2 and 4?
2 and 4 is 6.
Okay. Now these 2 and 4, what do they mean?
2 and 4 means...
What does this 2 mean?
The 2 means 20.
That means 20. It means 2 tens.
Yeah, 2 tens.
What does that 4 mean?
4 tens.
So what's 2 tens and 4 tens?
6 tens.
6 tens. What's 6 tens?
60.
We have the name for 6 tens is 60. So it's super easy to do in your head. Right? Over here, this one was easy to do too because we just took 30 and 9. Did you have to carry anything? Did you have to do any stuff like that? Just 39, right?
Nah.
Okay, that's why we start off with the easy ones like that, right? And we start off with the easy ones like this. Problems that are quote-unquote non-compound. Okay, and then we'll work our way up. Later on, we'll have ones where we do have it. Like say if I did this, I change it, and I change this. I'm going to change it, watch. I'm going to do this. I'm going to move this one over here.
How about
And I'm going to move this one over here.
Oh, so we're going to take mine away.
Yeah, just for a second. Now, how many goes there?
4. Oh.
Yeah, do it.
4.
Hey, he's using
It's
my
14,
pen.
and you need to put change. All we did was change the units, right?
He's using my pen.
It's fine. All right, so there's 14.
Okay, if you use my
Very
pen.
good, very good.
Here's my
Now, what's the total number there? If one side is 4 and the other side is 14. Well, now it's still 40 here, right? What do I have? What do I have here? How much is this? Couldn't stand it. How much is that?
16.
Alright, so what do I have? Total.
Okay, that was a little bit scary.
I couldn't wait to post it.
No, yeah, you couldn't. You were bursting.
But you were wild.
56.
There you go. Very good. Right? Just add them together, and we didn't have to do anything.
I went wild on that one.
Right? Terrible writing because I'm writing left-handed and upside down. But anyway, still. Right? See, how easy are these? So when we multiply teens are pretty darn easy. Okay. So instead of spending our time doing problems, what do I have? I have about 14, and I'll put a times there, and I'll put 4. Instead of spending all of our time, endlessly drilling like this, why don't we get some conceptual knowledge of multiplication, division, area, right? Compound lesson, compound teaching, where we learn a whole bunch of stuff all at once, and we see that definitely multiplication and division go together, don't they? It's like there's no such thing really as adding. You just combine. There's no addition and subtraction. You're just combining. But here, for sure, you can see we have inverse functions. If the whole thing is 32 and one side is 4, what's the other side have to be?
7.
What? If the whole thing is 32, yeah, the 7's for this one. If the whole thing's 32 and one side's 4, what does the other side have to be?
8.
8. If the whole thing is...
8 right there.
There you go. The whole thing is 32 and one side's 8. What's the other side have to be?
How do you write that?
It's fine. It's fine.
Okay.
4.
There you go.
Yeah.
If the whole thing is 18 and one side's 3, what does the other side have to be?
1 times 6.
Right? So if the whole thing is 18, one side's 3, the other side has to be 6. This is why we like math.
And 3
I was
times
doing a
6
lesson...
is 18.
Very good.
3 times 6 is 18.
Yep. I was doing a lesson with some little kids, and I do one... actually, they're your friends. And I do one where I take one student and do math, and the other student learns reading and spelling and writing and stuff like that, right?
Who are they?
Yep. And the teacher was out there trying to teach him how to spell and put words into ing. Like if you have reading or writing or jumping or hopping or singing, how do you spell it? And the rules behind it, where if it's a short vowel sound, then you double the consonant, and if it's a long vowel sound, then you just put it on there. And sometimes you have to drop it. And he was trying to figure out how to do it, and I leaned out my door and I just said, "This is why we like mathematics better than we like English, because in math, it's super easy. We can see what's going on every time. There's no exceptions, right? There's the same thing in science and the same thing in physics. We have certain laws. And if we discover exceptions, sometimes that changes everything, which is the simplest exception to a rule." And this is why I find, I was just looking at a great chart, I'll put that in here someplace, the proficiency in the United States for science. I think the highest scores are 44. We're proficient or better in science, which is why we have the government getting away with just the most ridiculous stories, that if people had more knowledge of science and mathematics, they could never tell the stories and get away with it. Now, and especially people that do English, because if you're used to English and language, well, of course there's exceptions to rules. Of course there's exceptions to physics. No, there's not exceptions to physics. No, there's not exceptions to mathematics. We follow nice, simple, easy rules. But if you're used to spelling, then of course you can wrap your mind around ridiculous lapses in physics on certain days of the year. Actually, only one day of the year in the whole history of man.
Daddy,
anyway, yes, you can if you want to. So, the idea is critical thinking skills, being able to do math, being able to count. And what are we doing? We're learning how to count quickly.
Yeah.
Right? Ask me a couple of them. Ask me some single digit by single digit multiplication.
3
Times what?
times 9.
3 times 9, 27. Done. See? That's just counting fast, right? 3 9s, 27. I don't have to count. Remember when you were a little kid? You used to have to count these. 3, 6. Actually, you used to count like this. 1, 2, 3, 4, 5, 6, right?
Yeah.
Okay. Well, now we've gotten faster than that. We count by 3s. 3, 6, 9, 12. Oh, and then we get really fast. 9, 18, 27. Done. And then we get even faster than that. I see 3 9s. I know it's 27. Right? I see 6 6s. I know it's 36. Alright, instant recall. I don't have to calculate. I don't have to count. I just know.
Yeah.
Right? That's what we're working toward, because multiplication is the ultimate milestone in mathematics. But we learn a bunch of stuff on the way, not just multiplication. Right? How much trouble are you trying to get in?
Hold on.
Alright. Now,
I like this process.
what? Ask me another one. 2 numbers. And you could make it single digit times double digit even if you want to.
How about this?
How about what?
8
No. 8 times what?
8 times
Wait.
15.
8 times 15. Good problem. 120.
Huh?
120. 120. Now what do I have?
I
8
think
times
it's
15. Let's do it in our head quickly. I have, think about it. How many 10s would I have? I'd have 8 10s.
Yeah, that's a good one.
Right?
Yeah.
And then what's 8 times 5? 40. So I add the 4 10s to the 8 10s. And I get how many 10s?
120.
I get 12 10s, which is 120. See it? How easy is that?
Easy.
Easy. Okay, what were you gonna say?
Lemon squeezy.
How about 7 times 5?
No, I was gonna do
How about 7 times 5? You guys do it. Much easier to grab 5s, little boy. 7 though. You only have 5 there. So you gotta use your imagination. Or you could actually just steal a couple. There you go. What do we have? 7 times 5.
What is that times that?
35.
Would you ever have, when you're counting by 5s, anything other than 5 or 0? Ever? Would you ever have 36?
35.
I know you did, but I'm just saying. You thought for a second. You thought 35. You're correct, but you were. But I heard you saying 36. No, 35. Is it ever gonna be 32? Would it ever be 40? Would there ever be anything other than a 5 or a 0 when we're counting? 5, 10, 15, 20.
It can't be 101 million.
Right. It couldn't be 101. It could, right?
Can't be 170.
It couldn't be. It could be 170.
Oh wait, yeah.
Okay. Let's talk about 6s.
How about we
How about 6 5s or 5
How about
6s?
we talk about 10s?
Well, 10s are easy. Yeah, you know it's easy, right? But let's talk about 6s. What's 6
How
5s?
about 1s?
6 5s. 6 5s.
5 6s.
Or 5 6s.
5.
25.
6 5s?
5.
That's only 5 5s.
30.
Ah, very good.
He's counting on.
He was counting on fingers, that's fine. But see, pretty soon we're going to get to the point where I say 6 times 5 and you just say 30. Don't have to count, don't have to do any calculation, right?
Yeah.
Okay, same thing when we do addends, when we do numbers. What's 7 plus... let's talk about adding some of these numbers. What's 6 and 6?
6 and 6 is 12.
Very good. What's 7 and 4?
11.
Very good. What's 5 and 5?
10.
That's too easy. What's 3 and 6?
9.
9.
Okay, let him answer. What's 4 and 8? Let's stop. 4 and 8.
14.
4 and 8.
Oh, I meant to say 13.
Really? 4 and 8.
12.
What's the answer?
12.
Are you sure?
Yeah.
Why are you sure?
I'm just going.
Because first you told me it was 14, then you told me it was 13. So why should I believe you now? What do I have? Show me that it's 12.
I just counted to make sure.
Okay. Well, show me. Well, how do you know?
Because I was like 8,
Mm-hmm.
4, and then that.
Okay. Well, can you see that you have a 10 and a 2 there?
I should have just done like this 4. That'd take too
You
long.
should have just done like that. You could do it 2 ways. One, put the 4 there.
Okay.
All right.
Or you just do that.
Look,
2 more 12.
it needs 2 and then 2 more, right?
12.
There's 2 left.
Yeah, 12.
All right. Goodness.
Easy peasy lemon squeezy.
All right. How about?
Or
Well, we
easy
have
peasy
what's 3 and
pumpkin
7?
juice.
This is fun.
Yeah. What's 3 and 7?
10.
What's 5 and 10?
Ooh, okay. 15.
Very good. You. What's 7 and 2? 7 and 2.
Oh yeah.
7 plus
9.
2.
9.
All right. What's 7 and 9?
Easy peasy pumpkin squeezy. Sorry.
What's 7 and 9?
7 and
63.
That's multiplying. I'm asking you to add them. What's 7 plus 9?
Air.
You are correct. It's 63 when I multiply. What is it when I add?
Is that multiplying by 9 or 6s?
16.
16. Very good. What's 5 and 8?
5 and 8.
Sit up nicely, boys.
5 and 8.
I'm just going to do a little pour before I
Okay. Good. Good. Figure it out.
13.
Very good. Can you see right there? Put it back. He was figuring it out over here by himself.
Yeah.
There you go. Can you see that 8 takes the 2 and there's 3 left?
Yeah. I was just trying to figure it out myself.
Yeah. Very good. Of course.
blocks.
What's 7 and 7?
14.
What is 3 and 13?
3 and 13.
Mm-hmm.
16.
Very good. Do we have any left? What's 4 plus 9? This one.
13.
Very good. Okay. Now, let's fool around with a little bit more. What's 7 minus 3?
7. I think I made 3 from 7.
Mm-hmm.
This is really the 7.
Now, if you've seen the algebra, you know why I'm doing this. And if you've seen the with negative factors, you definitely know why I'm doing this. Anyway, 7 minus 3. What's left?
4.
Very good.
I was just
4. 4 minus 7. In other words, I have 4. I'm going to take away 7.
Mm. 4 minus 7.
Mm-hmm.
Yeah. I don't do that.
0.
Nope.
4 minus 7.
Okay, 4. Stop.
Stop. I know. Well, stop it. Stop it. He's got it. And you're about to be in trouble with your dad. 4 minus 7.
3.
Is it 3? What kind of 3?
Negative 3.
There you go. And you could always just get it out. Right?
Okay, well-
There's my minus 7. There's my 4. What do I have?
Negative 3.
Negative 3.
Yeah, that was a little.
Alright. Were you going to say 3 or negative 3? Which one are you going to say?
3.
Okay. But it's negative 3.
I thought that
Okay,
was
right?
right.
How about if I had negative 7 minus 9?
7.
Minus 9.
Mm-hmm.
Negative.
Mm-hmm.
7.
Minus 9.
Negative 2.
Very good. Now here, we gotta put, he's trying to set it up, right? There's your negative 9. Put the 7 next to it. Now we can look at it. This is a hole 7 feet deep. Or 9 feet deep, sorry. And I fill it up 7. I still have a hole that's 2. Right? Or we can look at it. If you owe me $9 and you only have $7, you still owe me $2. I take everything, and then you still owe me 2 more.
Yeah.
Right? Okay. How about over here? What if I have 7 minus 2?
7. What? 7?
Minus 2 is what?
Can I get this out? 7.
You shouldn't need them for that one. But what's 7 minus 2?
7.
5.
There you go. Now you guys need to build more walls and make more 10s and play in the trays more and goof around so that numbers like that are super easy for you. But there you go. There is a lesson where basically what we have is two little boys fooling around with blocks, and then when we clear this thing off, counting, and we clear this thing off, look, it even looks like they had fun. You can see all the stuff that goes on when we take the board away. I'll stop. Let's put blocks away, and then let's not erase the board and just see what the board looks like.
I'm making a little wall.
Okay, cool.
No, I'm making it.
You're making an 8 wall? Alright, so you're going to make it higher?
Yeah, I'm just going to make it an 8.
Okay, just go ahead and make it an 8.
You just might make it a house for Harry Potter.
Sure, why not? Go ahead.
It's going to be fun.
That's going to be fun.
Put away.
Put away, let's put away, actually put away. Where we actually put them away. Put them in the right spots.
Piling it up. Okay.
Instead of just piling it up and making a mess.
Oh, that
Oh, look, we got all kinds of stuff in the 7 slot, so let's take it out of there. And then you can put
it exploded.
Yeah, put them away, please. God, there's all kinds of stuff over here. Look at that. Silly bands and guys and dough and all kind of stuff for making math fun. Alright. This part's boring, so we'll skip it. Apparently Harry Potter has to be built because he's made out of Legos, and you what do you have? You only have his head?
No, you don't. Where do you go?
Oh, you got him built? Okay. So now we can look at this, and we can see all the different things we've done here. 7 times 9, 63. We could put division symbols in there, and you can start seeing what's going on, right? Let's see. On this one, I guess we could put a division symbol in very easily. Because see there's 5. One side's 5, the whole thing's 40, the other side's 8. And over here, that 3 went with this 39. But anyway, you can see what we've got here. If we got square root 36, well, one side's,
yeah.
See that?
Yeah. All kinds of stuff.
All kinds of stuff we can do over here. We have over here, we have the whole thing is 50, one side's 5, the other side's 10. And over here I could make a rectangle, like just one side's 8, the other side's 4, the whole thing's 32.
Yeah, can I change my numbers and build a wall?
Yes.
I'm gonna do something.
Can you? Of course you can.
When I'm finished, I'll fold them.
Build a couple of walls, and then you could put the.
Oh wait, my brother just broke Harry Potter.
No, don't worry, you'll be fine. Anyway, you could build a little house for Harry Potter, or you could build a house for your men.
14.
Okay, there's a lot of numbers.
Right, you were counting just the numbers?
All the numbers.
Yeah. And see, it's fun to make more. We can do all kinds of stuff. Alright, anyway, so build some walls. You could build some walls so that your guys could fit underneath there. Cap your pen. Well, look, here's 2 guys right there. Where'd Harry Potter go?
Taller than my guy.
And look, here's a dinosaur. You could put it in there.
I'm trying to find something.
And here's a big monster. You could put it in there.
I'm trying to find.
Right. Anyway, so you could build a house.
What?
And you're gonna put a wall right here.
Daddy, I found something that might spill.
What?
It's under here.
He's under the table.
Why is water under there?
I don't know why there's water under there. Why don't you put that in the sink? That's strange.
Yeah, weird out my head.
All right, so just put it in the sink. Now, go and use the blocks and build some walls. And then we'll come back. Okay?
Yeah. Okay.
Okay. So now we've got this one built. There's nobody in there. Is there anybody in there?
You know what I was going to.
Yeah. Okay. So he built 10s, but you could easily put some 8s and 9s in there. And then I'm going to change this one up just a little bit.
There is somebody in
this
there.
One, yeah, you built some 9s. And you had a little help from your brother. They built them numerous times because they were knocking them over because they were fighting with each other and generally being little boys.
And
battling with the guys and so forth. There's some toys there. Anyway, so now I'm going to change this one up a little bit. And here's what I want you to do. I want you to build these 8s and 9s, except I want you not to use just one piece. I want you to use more than one piece. That's the only thing I'm going to say.
Look.
Okay?
I did this.
So we got this guy, he's on the roof.
Yeah.
And then we could put some other walls in if you wanted to.
And the protection unit.
And the projection unit, there you go. Anyway, play, just play, you're playing around, right? It can't be just an arduous task every time. You put them in a math-rich environment, they're gonna learn math, they can't help it. And we had a little accident when he was taken in the park because he was being a doofy head. And
he made me rebundle
nobody made you do anything. I just read something that was great. If you're gonna blame everything on somebody else, you're gonna have a bad time. It was off a meme, but I think the Dalai Lama said it. If you think
my fault.
everything is somebody else's fault, you're gonna have a bad time. All right. Anyway, so build it, and like I said, put the 8s in a set, and you can help him. You can help him build with 2 pieces to build 7s and 8s.
a really big house.
Yeah, it's nice. I like it. Think of all the motor skills.
A 3-story house?
Sure, you could build as many stories as you want.
Yes.
700-story house.
700-story house. It might take a little time, but anyway. So build that wall nicely. Look at your brother's wall.
1 million.
Your wall could be nice too. Make sure you.
1 million.
I made mine really nice and really wide so it doesn't fall down.
It's gonna take a long time for a 1 million story house.
Yeah, a 1 million story house. That would be a big house.
Huge house.
Huge house.
Taller than
Okay, so if you already have 9, can you build a 9 with a 3 and a 9? Can you build a 9 with a 3 and a 7?
Boop, boop, boop.
Right, oops.
Boop, boop, boop.
There you go. Alright, so we'll come back as he builds and so forth, but because your kids can do this, you don't need to have video of it, but I mean, just understand, play, and make stuff.
Yeah,
Right?
that's
Building
the whole
stuff.
point of math.
That's the whole point of math, is to play and have fun, right?
Yeah.
Yeah.
Not just to like mess around and not do anything fun.
Yeah.
That's not even a good point.
Yeah, I agree.
I just like to do the math. It's the funnest part.
Okay, so anyway, build that cool thing, you little architectural feature you had. Well, like I said, instead of using 1 9, use I don't care. Use whatever you want. Okay, see, isn't it? So a lot of stuff has happened since we turned off the camera. They had an hour of Chinese lessons, and then he came back and he built this cool structure with 9s and 8s. Wait, those are 8s. All of them are 8s. And then you put some stuff over there, and we could probably still put a roof on. Oh, look at that. Pretty cool, huh?
So now the guy.
And they're drinking vitamin C juice.
Yeah, look
Right
at
there.
that.
There is no soda in this house. When was the last time you guys got a soda in this house?
Since
Can you remember ever?
Since I was like 2 years old.
Yeah, I don't think you got soda when you were 2 for sure. Once in a while, they might get it at Christmas. But other than that, teas, vitamin C juice, right? The idea is feed the brains. When's the last time you had fish oil?
Just now.
No?
When?
This morning.
This morning. There you go. When's the last time, right? Vitamin B12, right? They get.
When
anyway,
did you get a B12?
Oh no. Well, then we'll get some in a minute. But the idea is feed the brains, feed their bodies, feed their minds, right? This is not stealing their childhood. It's fun. It's play, and get them ready for when they're older, so that they have all the tools they need to succeed in whatever it is they want to do. I would very much like it if these 2 little boys became scientists, or physicists, or mathematicians, or engineers. But you know what? If he wants to do music, or if he wants to do journalism, or if he wants to be a writer, or a poet, or a whatever it is,
want to be a drummer.
or a drummer,
I'm the one who wants to be a singer.
and then maybe you want to be a singer, fine. But it's not because they can't do mathematics. And if they want to go down that road, they can go down that road. And how do you do it? You play. All right. Where can they go for more information?
Crewton Ramone.